NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
10 decades in space, everyone might possibly think Voyager 1 is old and broken. That's not the story for this space probe that recently discovered monumental feats. NASA must be worried or fascinated about these unraveling secrets of the universe. Thanks to Voyager 1, after over 50 years, it's still perfectly sending codes to humanity. Let's start diving. Dynamic interstellar medium. Ever since humanity first looked up at the stars, we imagined the vast emptiness between them to be calm and uniform, a quiet void punctuated by isolated celestial objects. But thanks to Voyager 1, our long-standing notions are getting a serious upgrade. The spacecraft's latest plasma wave measurements have revealed a surprising truth. The interstellar medium, the stuff between the stars, is far more dynamic, turbulent, and structured than we ever imagined. Voyager 1, which has been cruising through space for over 4 decades, is now sending back data that's shaking up our understanding of what lies beyond our solar system. At the heart of these findings is the detection of charged particles, or plasma, in interstellar space. Scientists had long predicted that once you leave the influence of our Sun, the environment would become relatively uniform and peaceful. Instead, Voyager 1 instruments have shown that the density of this plasma is not only higher than expected, but also fluctuates in ways that suggest a bustling, ever-changing cosmic neighborhood. Dream up expecting to walk into a quiet, empty room, only to find a lively dance party in full swing. That's pretty much what Voyager 1 discovered out there. The charged particles in interstellar space don't just sit idly by. They're zipping around, creating a dynamic environment that's anything but static. This turbulence means that the space between the stars is more like a cosmic ocean, with waves, currents, and eddies, all playing their part in a grand celestial dance. So why does this matter? For one, it challenges our traditional models of the heliosphere, the bubble-like region dominated by the solar wind, where our Sun's influence still holds sway. When Voyager 1 crossed into interstellar space, many scientists expected a neat, clean boundary marking the transition from our solar system to the wider galaxy. Instead, what we see is a fuzzy, complex border where the density and behavior of particles shift in unexpected ways. This discovery forces us to rethink how the solar wind interacts with the interstellar medium, and, by extension, how energy and matter move through our galaxy. Beyond just tweaking our models, this discovery opens up a treasure trove of questions about the nature of the universe. For example, what exactly drives the turbulence in this cosmic medium? Could these variations in plasma density influence the formation of stars, or the propagation of cosmic rays? Each new data packet from Voyager 1 is like a piece of a giant cosmic puzzle, gradually revealing a picture of a universe that is far more active and interconnected than we ever thought. What's really cool is how this revelation underscores the idea that space is never really empty. Instead, it's filled with a complex, ever-changing mix of particles and energy. The dynamic interstellar medium serves as a reminder that our galaxy is a vibrant, living system. Even in the vast expanses that seem isolated and quiet, there's a hidden symphony of forces at work, shaping everything from the smallest particles to the largest structures in the universe. Voyager 1 journey is a perfect example of how persistence and curiosity drive scientific discovery. Launched during the height of the space race, this spacecraft has outlived many of its contemporaries, continuing to send back valuable information that challenges our assumptions and fuels our imagination. It reminds us that even decades-old technology can lead to groundbreaking insights, proving that exploration, whether it's of our own backyard or the far reaches of space, never truly ends. The discovery of a dynamic interstellar medium is more than just an adjustment to our scientific models. It's a testament to the complexity and beauty of the universe. Every ripple in the plasma, every unexpected fluctuation, tells a story of cosmic interactions that have been unfolding for billions of years. And thanks to Voyager 1, we're privileged to get a front row seat to this grand performance. So next time you look up at the night sky, remember that the space between the stars is not a silent void, but a vibrant, dynamic arena full of energy, mystery, and endless discovery. Magnetic field mysteries. Let's say you're expecting a dramatic fireworks display at the boundary of your favorite park, only to find that the grand finale is a soft, subtle glow instead. That's a bit like what scientists have found at the heliopause, the boundary where the solar wind gives way to the vastness of interstellar space, thanks to Voyager 1's trusty magnetometer. For decades, our models painted a picture of the heliopause as a clear-cut line, a dramatic transition where the magnetic field would shift sharply as you moved from the influence of the sun into the mysterious interstellar medium. It was like expecting a wall of sound at a concert that suddenly drops into a whisper. However, Voyager 1 recent readings have thrown a cosmic curveball at these expectations. Instead of witnessing an abrupt change in the magnetic field, the spacecraft found that the magnetic field didn't change as drastically as we thought it would. This gentle transition is both surprising and exciting, because it challenges the way we think about the interaction between the solar wind and the interstellar environment. Again, what does this mean? First off, it suggests that the boundary between our solar system and interstellar space isn't as dramatic or as clearly defined as earlier models had us believe. The solar wind, essentially the outflow of charged particles from the sun, was expected to collide with the interstellar medium in a way that created a noticeable magnetic shock or barrier. Instead, Voyager 1 is hinting that the interaction is more like a slow dance, where the magnetic fields gradually merge and blend rather than clashing head-on. This finding opens up a lot of questions. If the magnetic field isn't making that dramatic leap at the heliopause, then what exactly is happening at this boundary? It seems that the forces at play are more complex than we initially thought. The interstellar medium itself has its own magnetic quirks, and these new observations suggest that the interplay between the sun's magnetic field and that of the interstellar environment might be subtler, more interconnected. It's as if the two fields are in a friendly chat rather than an explosive argument. One of the coolest parts of this discovery is how it invites us to rethink the big picture of our cosmic neighborhood. The heliopause isn't just a neat dividing line. It's a region where the solar wind gradually surrenders its dominance to the broader and perhaps equally intricate interstellar forces. This soft transition might influence everything from the way cosmic rays travel through space to how particles and energy are distributed in our galaxy. In other words, understanding this process better could unlock new insights into the fundamental workings of the universe. Voyager 1 has been our tireless explorer, sending back data that continuously pushes the boundaries of our knowledge. Its magnetometer, the tool responsible for measuring the magnetic field, is proving that even after decades of exploration, space still holds plenty of surprises. What might have seemed like a predictable drop-off in magnetic strength has instead turned into an invitation to explore the complex dynamics at the edge of our solar system. It's a reminder that space is rarely as straightforward as our initial models suggest. Just when we think we have everything neatly sorted out, the cosmos throws us a curveball, prompting us to refine our theories and explore new possibilities. The seemingly gentle transition in the magnetic field at the heliopause is more than just a scientific oddity. It's a clue to the intricate dance of forces that shape our galaxy. In the end, Voyager 1 findings are a testament to the enduring mystery and complexity of space. They remind us that even at the edge of our solar system, where we might expect clear boundaries and neat divisions, the universe is a blend of gradual changes and simple interactions. And isn't that a lot more interesting than a simple, dramatic divide? When you look up above, think of Voyager 1 quietly cruising along, capturing the soft hum of the cosmic dance at the heliopause, a gentle whisper of the magnetic field, telling us that the universe is always ready to surprise us, even when we think we know it all. Fresh look at the heliosphere. What if you're trying to map out the border between two countries with a crisp, clear line? Now, picture finding out that the border is actually a messy, winding area where cultures blend and the rules aren't so clear-cut. That's pretty much what scientists are discovering about our heliosphere, the vast bubble created by the solar wind that surrounds our solar system. For a long time, our models of the heliosphere were built on the idea of a neat division. Inside, we had the solar wind ruled by our sun, and outside lay the wild, uncharted territory of interstellar space. It was like thinking there was a clear on and off switch when transitioning from our cosmic backyard to the broader galaxy. However, thanks to recent data from deep space probes like Voyager 1, we're now seeing that the changeover isn't as simple as flipping a switch. The latest findings suggest that the transition from the solar-dominated environment to interstellar space is more like a gradual fade-out rather than a sudden cutoff. It turns out that the boundary is a complex, dynamic region where the solar wind doesn't just stop abruptly, but blends, interacts, and evolves with the interstellar medium. It's a bit like watching the colors of a sunset slowly merge together, rather than switching instantly from day to night. What does this mean for our understanding of the heliosphere? For starters, it challenges scientists to rethink the models that have long been accepted. The simplistic picture of a defined edge is giving way to a more intricate tapestry of cosmic interactions. The data shows that the solar wind and the interstellar medium don't just crash into each other at a clean boundary. They mix in a zone that's more complex and dynamic than we imagined. This evolving view has significant implications. A more nuanced understanding of the heliosphere means that we have to revisit how we think about everything from the behavior of cosmic rays to the way our solar system interacts with the rest of the galaxy. It's like discovering that your favorite recipe has a secret ingredient that changes everything about the final dish. Each new observation is a clue that pushes us to adjust our models, refine our theories, and ultimately gain a clearer picture of our place in the universe. At its heart, this ongoing refinement of the heliosphere model is a testament to the ever-evolving nature of science. It's a reminder that our cosmic neighborhood is far more complex than we ever assumed. The universe rarely conforms to our expectations. It's full of surprises that challenge our understanding and invite us to keep exploring. These discoveries are more than just tweaks to scientific models. They're a call to embrace the complexity of the cosmos. The heliosphere, once thought to be a simple bubble, is actually a vibrant, dynamic interface where solar and interstellar forces converge. And that, in turn, gives us an even richer narrative of how the universe works. Now, let's take a look back to everything discovered through Voyager 1. All Voyager 1 discoveries. Launched on September 5, 1977, Voyager 1 has become one of humanity's most remarkable achievements in space exploration. Its primary mission was to study the outer planets of our solar system, but it has since ventured into interstellar space, making groundbreaking discoveries that continue to reshape our understanding of the cosmos. Thanks to this spacecraft, we knew about the enormous planet, Jupiter. Voyager 1. First significant milestone was its encounter with Jupiter in March 1979. The spacecraft captured stunning images of the planet and its moons, revealing unprecedented details about its atmosphere, magnetosphere, and moons. Among its most notable findings were the discovery of active volcanism on Io, one of Jupiter's moons, marking the first time volcanic activity was observed beyond Earth. It also revealed Europa's smooth, icy surface, sparking speculation about subsurface oceans that might harbor life. Additionally, Voyager 1 provided detailed images of Jupiter's Great Red Spot, a massive storm system, and mapped the planet's faint ring system. In November 1980, Voyager 1 reached Saturn, delivering new insights into the planet and its complex ring system. The spacecraft captured detailed images of Saturn's rings, revealing intricate structures such as radial spokes and wave-like patterns caused by gravitational interactions with the planet's moons. It also provided close-up views of Saturn's largest moon, Titan, which revealed a thick atmosphere composed primarily of nitrogen and methane. This discovery suggested the possibility of organic chemistry on Titan, laying the groundwork for future missions like Cassini-Huygens. After its planetary encounters, Voyager 1 embarked on its interstellar mission, continuing to send data from beyond the solar system. In August 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the solar wind gives way to the interstellar medium. This milestone marked its entry into interstellar space, where it began studying the plasma density, magnetic fields, and cosmic rays of this new environment. One of its key discoveries in interstellar space was the measurement of plasma density, which revealed that the interstellar medium is denser than the outer regions of the heliosphere. This finding has helped scientists better understand the interaction between the Sun's influence and the broader galaxy. Voyager 1 has provided invaluable data on cosmic rays, high-energy particles originating from outside our solar system. It detected an increase in cosmic ray intensity upon crossing the heliopause, confirming its entry into interstellar space. Additionally, Voyager 1 magnetometer has been instrumental in studying the magnetic field in interstellar space, offering insights into how these fields influence cosmic ray movement and the structure of the interstellar medium. While not a scientific discovery, Voyager 1 Golden Record deserves mention for its cultural significance. This time capsule contains sounds, images, and messages representing the diversity of life and culture on Earth. As Voyager 1 continues its journey through the galaxy, the Golden Record serves as a symbolic gesture of humanity's desire to connect with the universe. Even after more than 45 years in space, Voyager 1 continues to make valuable contributions to science. Its instruments, though aging, still function well enough to transmit data about the interstellar environment. These ongoing measurements provide a unique perspective on a region of space that remains largely unexplored. Voyager 1 discoveries have had profound implications for planetary science, astrophysics, and our understanding of the universe. Its journey has inspired generations of scientists, engineers, and dreamers, proving that human curiosity knows no bounds. The discoveries made by Voyager 1 represent some of the most significant achievements in the history of space exploration. From revealing the volcanic activity on Io to venturing into interstellar space, the spacecraft has expanded our knowledge of the solar system and beyond. As Voyager 1 continues its silent journey through the cosmos, it stands as a testament to humanity's enduring quest to explore the unknown and uncover the mysteries of the universe. The Golden Records. Both spacecraft carry the Golden Records, phonograph records containing sounds and images that represent the diversity of life and culture on Earth. These records were designed as a time capsule, intended to communicate with any extraterrestrial life that might encounter the spacecraft. While both records are identical, they symbolize humanity's hope and curiosity for making connections beyond our solar system. Together, Voyager 1 and Voyager 2 have transformed our understanding of the solar system and interstellar space. Their data have contributed to numerous scientific discoveries, from the dynamics of planetary atmospheres to the structure of the heliosphere. They also serve as symbols of human ingenuity and the spirit of exploration, continuing to operate far beyond their expected lifespans. Voyager 1 and Voyager 2 are twin spacecraft that have taken different paths but share the same mission of exploring the cosmos. While Voyager 1 was the first to enter interstellar space, Voyager 2's extended planetary mission and functional plasma instrument have provided unique insights into the outer planets and the boundary between the solar system and interstellar space. Together, they have offered humanity a deeper understanding of our place in the universe, inspiring generations of scientists and explorers to continue reaching for the stars. Its life expectancy Voyager 1, launched in 1977, is humanity's most distant spacecraft and a remarkable testament to engineering and exploration. After more than 4 decades in space, the spacecraft continues to send data back to Earth, but its mission is inevitably approaching its conclusion. Understanding how long Voyager 1 will last requires considering factors like its power supply, instrument functionality, and the challenges of operating in deep space. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, which convert heat from the decay of plutonium-238 into electricity. When it was launched, these RTGs generated about 470 watts of power. However, the energy output decreases by about 4 watts per year as the plutonium decays. As of 2025, Voyager 1 has about 250 watts of power remaining, and mission engineers have been systematically shutting down non-essential systems to conserve energy for critical instruments. NASA estimates that Voyager 1 will lose the ability to power its scientific instruments by the early 2030, likely marking the end of its ability to collect and transmit meaningful data. Voyager 1 carries several scientific instruments designed to study the interstellar environment, including its plasma wave subsystem, magnetometer, and cosmic ray detector. Despite their age, many of these instruments are still functioning and providing valuable data. However, as the power supply dwindles, these instruments will be gradually turned off to prioritize essential systems like communication. Even if power were not an issue, the wear and tear from decades of operation in the harsh environment of space would eventually render the instruments less reliable. Voyager 1 communicates with Earth using the Deep Space Network, a system of large radio antennas. Given its immense distance, currently over 15 billion miles, 24 billion kilometers from Earth, signals take more than 22 hours to travel each way. Maintaining communication requires precise alignment and robust technology, but as the spacecraft continues to drift farther, the signal strength will weaken and communication will eventually become impossible. Even after Voyager 1 instruments and communication systems cease to function, the spacecraft will continue its journey through interstellar space. Traveling at about 38,000 miles per hour, 61,000 kilometers per hour, Voyager 1 will remain a silent ambassador of Earth, carrying its golden record, a time capsule of sounds, music, and images representing humanity, intended for any intelligent life it might encounter. Over the next tens of thousands of years, Voyager 1 will pass relatively close to other stars, such as Gliese 445, approximately 40,000 years from now. While it will no longer be operational, its journey will continue, symbolizing human curiosity and exploration. Voyager 1 is nearing the end of its operational life, with its power supply expected to run out in the early 2030. Despite this inevitable conclusion, its contributions to science and its symbolic value will endure far beyond its active years. As it ventures deeper into interstellar space, Voyager 1 will remain a beacon of humanity's desire to explore the unknown and reach for the stars. Meaning of life through Voyager 1. Exploration. Since its launch in 1977, Voyager 1 has become more than just a spacecraft. It is a symbol of humanity's quest to understand the universe and our place within it. While its primary mission was to explore the outer planets, Voyager 1 has taken on a profound philosophical role as it ventures into interstellar space, carrying with it humanity's curiosity and the hope of finding answers to the most fundamental question: what is the meaning of life in the universe? Voyager 1. Scientific discoveries have provided humanity with an expanded understanding of the cosmos. From its close-up images of Jupiter and Saturn to its measurements of interstellar plasma, the spacecraft has offered insights into the conditions that shape planetary systems and the vast, unexplored interstellar medium. These discoveries provoke deeper questions. Is life unique to Earth, or is it a universal phenomenon? By studying the environments of moons like Europa, which may harbor subsurface oceans, Voyager 1 laid the groundwork for the search for extraterrestrial life. Such missions challenge the anthropocentric view of the universe, suggesting that life could arise in conditions vastly different from those on Earth. This possibility has profound implications for how humanity perceives its role in the cosmic order. Voyager 1. Golden Record embodies humanity's hope of making a connection with intelligent life elsewhere in the universe. The record contains sounds, images, and greetings from Earth, showcasing the diversity of life and culture on our planet. Its inclusion in the Voyager mission reflects a profound belief that the search for meaning extends beyond scientific discovery to a desire for communication and understanding. The Golden Record symbolizes a universal yearning for significance. If an alien civilization were to discover Voyager 1, it would serve as evidence that humanity once existed and sought to share its experiences and aspirations. This act of sending a message to the cosmos highlights the deeply human need to leave a legacy and find purpose beyond our immediate existence. One of Voyager 1's most iconic contributions is the pale blue dot photograph, taken at Carl Sagan's suggestion as the spacecraft looked back at Earth from a distance of 3.7 billion miles. This image captures Earth as a tiny speck suspended in the vastness of space, underscoring the fragility and uniqueness of life on our planet. Sagan's reflection on the image emphasized the unity of humanity and the need to cherish our shared home. The photograph serves as a reminder that the search for meaning is not just about discovering life elsewhere, but also about recognizing the value of life on Earth. It challenges humanity to look inward and strive for greater compassion, cooperation, and stewardship of our planet. As Voyager 1 travels deeper into interstellar space, it continues to explore uncharted territory, symbolizing humanity's relentless pursuit of knowledge. Its journey raises questions about the ultimate purpose of exploration. Are we searching for evidence of life elsewhere to validate our own existence? Or are we driven by an innate curiosity to understand the universe, regardless of whether it holds answers to the meaning of life? Voyager 1 mission highlights the interplay between science and philosophy. While its instruments measure physical phenomena, its journey inspires metaphysical contemplation. It represents a bridge between the tangible and the transcendent, offering a framework for considering humanity's place in the cosmos. Voyager 1's exploration of the universe is not just a scientific endeavor, but a deeply philosophical one. Its discoveries, the golden record, and the pale blue dot image all contribute to humanity's ongoing search for meaning in the vastness of space. As it ventures further into interstellar space, Voyager 1 reminds us that the quest to understand life's purpose is both a scientific and a spiritual journey. It challenges us to look beyond our immediate surroundings, to cherish the life we know, and to continue seeking answers to the mysteries of existence. In doing so, Voyager 1 becomes more than a spacecraft. It becomes a symbol of humanity's enduring hope and boundless curiosity. The need for exploration. Voyager 1 and similar spacecraft represent a significant investment that has yielded far-reaching benefits in scientific discovery, technological innovation, cultural inspiration, and economic growth. While space exploration demands substantial financial and logistical resources, the returns, in both knowledge and progress, are profound. One of the strongest justifications for missions like Voyager 1 is the unprecedented scientific insight they offer. Voyager 1 has transformed our understanding of the solar system and beyond. It captured detailed images of Jupiter and Saturn, revealing active volcanoes on Io and the dense, intriguing atmosphere of Titan. Its journey beyond the heliosphere has provided groundbreaking data on plasma densities, cosmic rays, and magnetic fields in interstellar space. These findings refine our comprehension of the universe's structure and behavior, helping answer fundamental questions about its origins and evolution. Other missions, such as the Mars rovers and the James Webb Space Telescope, have similarly expanded our knowledge of planetary geology, atmospheric conditions, and cosmic history. By deepening our understanding of both our solar system and distant galaxies, these missions inform our view of Earth's place in the cosmos and lay the groundwork for future explorations. Technological advancements born from space exploration have had far-reaching applications. The challenges of sending and operating spacecraft drive innovations in engineering, materials science, robotics, imaging systems, and artificial intelligence. These technologies, initially developed for navigating and studying space, now enhance everyday life in fields like healthcare, transportation, and telecommunications. Economic benefits also arise from these ambitious projects. Space programs stimulate high-tech job creation and encourage partnerships among governments, private companies, and academic institutions. The commercial space sector, exemplified by companies like SpaceX and Blue Origin, has flourished partly due to the foundational research and technological breakthroughs pioneered by earlier missions such as Voyager. Furthermore, The development of reusable rockets and other cost-saving technologies is making space exploration increasingly efficient and affordable. The cultural and inspirational value of these missions is equally significant. Voyager 1 carries the golden record, a time capsule of Earth's sounds and images that symbolizes humanity's curiosity and desire to connect with the cosmos. Iconic images like the pale blue dot remind us of our planet's fragility and the unity of life on Earth. Such achievements inspire generations to pursue science, technology, engineering, and mathematics, STEM, fostering global collaboration and a shared sense of wonder. Critics contend that the billions spent on space exploration might be better directed toward addressing urgent issues on Earth, poverty, healthcare, and climate change, for example. However, proponents argue that these expenditures are modest relative to other budgets such as defense, and that the long-term benefits of scientific discovery and technological innovation far outweigh the initial costs. In an era marked by global challenges like climate change and resource scarcity, the insights gained from space exploration may also offer practical solutions. Studying other planets enhances our understanding of Earth's climate systems, while ventures such as asteroid mining could help alleviate resource shortages. Ultimately, investments in spacecraft like Voyager 1 not only expand the boundaries of human knowledge, but also affirm our potential to innovate, explore, and secure a brighter future for generations to come. Tell us your thoughts about the old but gold Voyager 1. For more updates and videos like this, subscribe to our channel. Thanks for watching.